Hey, fellow mathers! Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or rote memorizing facts, but it's about thinking and reasoning, about creating and using mental relationships. Y'all, we take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
So in the last episode, we did some higher math, right? And we were writing the equation of a line based on patterns.
Yeah, and it was a lot of fun. And you had so much fun. We
Yeah.
decided we would do it again.
Yay.
When we were planning for this, y'all, I have to tell you, Kim was like, really? You're going to make me do it again? I was like, come on. It was fun. It was good.
It's great.
It was, right?
I'm super willing. Yep.
So I appreciate your willingness. And it is kind of fun. And it was fun for me to write a brand new string. So this was a little untested, untried, untrue. No, it's true. It's just a little untested and untried, but it's about to be. It's about to be tested and tried. Here we go.
All right.
Hey, maybe if this one goes really short, we could talk about what I thought about when I wrote the string. It probably won't go short. But
It won't go short.
Time. Okay, here we go. All right, here we go. So problem string to all about writing the equation of a line. And we're just going to suggest that we could do this without having a lot of background. Like there doesn't need to be a whole lot of, probably should have started the episode with that. Hey, if you don't have a lot of background, hang on, because I think you can think about relationships. However, you might want to have a pencil handy because
just about to ask. Okay.
You're probably going to want to write these down. I would not be able to hold these in my head. I would need to be able to see, because I'm going to give you a bunch of points and then ask you what would the equation of the line that contains these points. Okay.
Oh my goodness. Okay.
All right. So listeners, hit pause, go find a pencil and a piece of paper and write down these points. So what about the point -2.2, comma 2.2? So that's a point. Okay. -2.2, 2.2 is a point. Then there's the point 1/2, comma -1/2.
Okay.
And the point 7, comma -7. So I'm just going to give you those 3 points.
Okay.
And I'm wondering if you just talk out loud as best you can. What are you thinking when you see those 3 points?
Okay. So the first thing I did, honestly, was I sketched out a coordinate. I don't even know what you call it.
Coordinate grid,
yeah,
axis.
Yeah. And I didn't put a whole lot on there, but I was trying to visualize where those points would go.
Mm-hmm.
And so I recognize obviously that the x is negative 2.2, and then so I knew that it was going to be like in the second quadrant.
That first point.
Yeah.
Okay.
And then the y of the second point is negative, and the third point as well. So those were going to be, I knew they were going to be like a little further down because they were negative.
Because the y's were negative.
Yeah.
Did you actually sketch the 3 points?
I did.
Does it look like they lie on the same line?
Yes, based on my not probably awesome sketch.
You could,
but yes,
Feasibly, they could be on the same line.
Yes.
Okay.
They
Okay.
look like they would
Okay.
be.
Okay. Cool.
Gosh.
Do you notice anything else?
So the 7, -7, I feel like obviously there's going to be a bunch of points in between, but I'm kind of wanting like a few more points in between the half, -half, and the 7, -7.
Yeah.
So
To
I'm
kind of
kind of like visualizing what some of them would be.
like what might they be?
I'm not sure.
Like if I went over 3, about how far down do you think I'd go to stay in that pattern?
I feel like you would go down 3 as well. Like I'm wondering in my head, would 6, -6, and 4, -4, and 2, -2 all be on that line?
And it seems like you're saying that every time you have an x value, the y value is going to be that same number, but
Yeah, but opposite.
negative. But yeah, the opposite
Mhm,
sign.
mhm.
So it almost sounds like you're saying that all the y values are going to be equal to the opposite of the x values.
Yeah, yeah.
And so I just literally wrote down. So then all y equals negative x.
Yeah. Yep.
And that would be the equation y equals negative x.
So you know what? It's interesting. I want that to go through the origin
Say more about that.
because based on like just probably memory, I want y equals x and y equals negative x to go through the origin because I want it to say y equals x and
plus 0. You sort of have that b. You're kind of remembering this b thing about the intercept, and since it's plus 0, you're like, I think the y-intercept's 0.
Yeah.
Let's see if 0, 0 fits your pattern. Is 0 equal to the opposite of 0?
Is 0 equal to the opposite?
Like to negative 0?
No.
Yeah, kind of, because 0 doesn't really have a sign.
Well, so okay. All right.
So yeah,
I mean,
0 fits.
Zero is the same as -0. I mean, I guess.
Yeah.
All right.
Yeah. Weird, right?
Yeah, that's a little weird.
All right, that was our first problem in the string. You ready for the second problem in the string?
Sure. Okay.
Nice. All right, nicely done.
It took a lot of paper to draw my picture.
Okay. Super job telling us what you're thinking about. That's excellent.
Okay.
Like, well done. Okay. So here's I'm going to give you 3 more points again. So the first point is -2, -1.
Okay.
0, 1, and 5, 6. 5, 6. And you're making me want to sketch these, which I hadn't totally done before when I wrote it.
I like to sketch them. Okay, so my line is going to go in the opposite direction, right? Like it's positive. It's a positive line.
Positive rate or positive slope. Okay. That seems important. Okay.
I'm looking between the points, to be honest. I'm looking less at my my graph, and I'm looking between the points to see if I notice anything.
Okay. Do you notice anything? It's a positive slope. That was a good first notice.
Yeah.
I feel like we need Jeopardy music. No,
but I appreciate the time. No, okay, so I'm noticing that between the x and the y, it's increasing by 1. I don't know if I'm saying that right, but from 5 to 6 is +1, and then from 0 to 1 is +1, from -2 to -1 is +1.
Yeah, that seems important. So I might record what you just said as I could find the y value. So I just wrote down y equals x. +1. Okay, there you go.
Sorry, was that right?
So I think I might have been talking over, but y equals x + 1. The y values were all the x values +1.
Okay.
Yeah, there's the equation of that line. Nice.
Okay.
I was a little curious to see, since you'd mentioned the y-intercept in the last group that we were doing, I wondered if you noticed anything about a y-intercept in this problem.
Oh, because it's +1.
So do you see that 0, 1 being the y-intercept?
Yes.
Don't be disappointed. It's okay. Like you can just connect.
I stared at it for a second. Okay, cool. Yeah.
Well, there it is, right? So y equals x + 1. There's the +1 as the b as that y-intercept. Cool.
Okay.
And the slope is positive, right? Because it's 1x. So all those things you noticed actually played out. Nice. All right.
Cool.
Let's do the problem number 3, a third problem in our string. Okay, this time I'm going to give you 4 points. So -1, -3 is the first point. 0, 0, 2, 6, and 5:15. 5:15. So I'm just going to repeat those for the people on the radio podcast. You just keep working, Kim. So -1, -3, 0, 0, 2, 6, and 5:15.
Oh, I'm glad you said that again because I wrote -1, 3.
Ooh,
And I was
-1,
very
-3.
confused
I may have
about
said it
why
wrong.
it's not
Sorry.
making a line.
I love how you're sketching them.
I am sketching them. Sorry it's taken a while. Maybe that gives everybody a chance to think.
So, I mean, really, you're actually doing this live. So that's kind of cool.
100%. Oh, that's gonna. Oh, okay. So I just tried to put 5:15 and I had no space, and I made my pencil go like way up off the page. Okay, so I think there's a lot of. This is going to be so wrong. I'm not saying this properly. There's a lot of gap between the points. Like I'm noticing that there's like I don't even know how to describe what I'm noticing. It's like increasing 3 times.
Like it feels really steep, it sounds like.
Yes.
Like because I've given you a lot of lines that had a slope of 1.
Mm-hmm.
And I think you're feeling that this one has a higher rate.
Yep.
It's like increasing faster. Okay.
Mm-hmm.
Cool. I like it. And something about 3?
Mm-hmm.
What about 3? Like why? That's random. What 3 what?
Oh, okay. I see it now. So between the points, it's 3 times. I bet I can do this. So y equals 3x.
Why?
Because for each of those points, the y is 3 times the x. And I can see that on the graph. That's really nice.
That you can see how steep it is, that it's over 1 up 3.
Yeah,
cool.
As soon as I couldn't put 5:15 on the graph, I was like, wait, that's way up there.
That's way, that feels really steep. Nice. Yeah. So you could see that like 15 was 3 times 5 and 6 was 3 times 2. And
it's funny because I'm not looking at maybe I should be looking at the points before I go sketch. I automatically go sketch. So I'm going to look at the points for the next one and see if I can see the relationship there first.
Well, I'll just let you do that.
Okay. I probably won't be able to see it.
Here is the last problem in our string. This is fantastic. All right, 4 points again. Here we go. -4, -2.
Okay.
-2, -1.
Mm-hmm.
0, 0. Mm-hmm. And 5, 2.5. I'm going to say those again for podcast listeners. Right. -4, -2. -2, -1. 0, 0. 5, 2.5.
Got it. As soon as I look at the points, that was a poor choice on my part. But you know what? Like I like the fact that I could see the first thing I did when I was trying to be comfortable was go to the graph. Mm-hmm. But when I started looking at the points first on this one, I recognized
just the coordinates.
Yes. The coordinates. I recognized I was going actually from y to x, and I was like, oh, it's doubling. It's doubling. But then when I started writing y equals, I realized, oh, wait a minute, it's not doubling, it's halving. So I mean,
it sort of depends on the perspective you look at it from, right? Like you could write it either direction.
Right.
So what did you end up?
I ended up with y equals 1/2 x. Cool.
Because if I look at any x value and I multiply it by 1/2 or divided by 2, you get the y value. Mm-hmm. So I wonder, we could actually think about the other direction. Like you said, the x value was twice the y value. So you could write x equals 2y.
Yep.
Which is an equivalent form of the equation outline. We just usually write it as y equals, but you could sort of have it either way.
Okay. All right.
Cool.
All
right, y'all. Could we really look at patterns to write the equation of a line? I think we can. I think that you just heard some really good thinking live as we sort of like from somebody who hasn't really written the equation of a line for a while.
Oh gosh,
a few years.
A few decades.
Yeah, and so could we use intuition to help people like what's really happening is it has everything to do with the patterns between the x values and the y values, and we can learn a lot about slopes and y-intercepts and things before maybe we get a little bit more into other ways. Now, do I want other ways to write the equation of a line? Yes, though you might be surprised about how much I want those to be based on relationships and connections and not rote memory of a formula as well. All right, that was fun. Woo! Math.
And it turns out writing the equation of a line is figure outable.
And so there you go. Excellent. Well said. So, everyone, if you want to learn more mathematics and refine your math teaching so that you and students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.